Class, good afternoon. So, another topic in power plant engineering. So, we have here cooling tower. So, actually, cooling tower may be presented in three parts. Okay? So, by this time, so we are going to discuss to you the theory involved in a cooling tower. So, this is the part one of my presentation. Okay? So, cooling tower. Whose function is to reject heat to the atmosphere. So by reducing the temperature of water circulated through condenser or other heat rejection equipment. So this is a device in which recirculating condenser water from a condenser or cooling coils is evaporatively cooled by contact with atmospheric air. So there are two types of cooling tower. First, we have the atmospheric or natural draft cooling tower. So, this is also divided into two. The first type is the deck type, and the other is the spray type. Another, we have the so-called mechanical draft cooling tower. So, this is also divided into two. One is the for forced draft, another is the induced draft. Okay. So we have here the schematic diagram of a simple cooling tower. So we have here at point 4 or we have TB. So meaning this is the cold water. Okay? So the water coming from here will now be towards the maybe the engine or diesel engine, maybe in a condenser or whatsoever. Okay? This is now the cold water. So at the top, the hot water will enter now at this point. Okay? So at point 3. So the hot water coming from the diesel engine will enter at this point or at the top of the cooling tower. Okay? So, another at the top is of course the exit of the air circulating inside the cooling tower. Okay? And at 1, of course, this is the entrance of the air. Okay? And at 5, this is now the make up water. So, we're in the water carried by the air will be replenished by means of a make up water. Okay? So this is the basic illustration or diagram of a cooling tower. Okay? So we have some terms or definitions in the cooling tower. So first is the cooling range. So what is a cooling range? Cooling range, this is the difference between the entering and leaving water temperature. Okay? So, entering meaning this is at point 3 and leaving is at point 4. So, meaning the difference of that is now called cooling range. Another is the approach. Okay? Approach is the difference in temperature between the cold water and the entering air with bulb. Okay, so the temperature of water at point 4 minus the temperature or the with bulb temperature of air entering the tower is called the approach. Okay, so take note of the uh, terms involved in cooling tower. Okay? Another, we have the cooling tower efficiency. Okay? So, or the effectiveness. So, efficiency measures the effectiveness of the mechanical equipment or the tower. Okay? So, this is the ratio of the actual cooling range to the theoretical cooling range. Okay? So, the theoretical range, of course, is the difference between the temperature of entering water and the temperature of the leaving water, or meaning the difference between the temperature of the hot water and the cold water. And of course, the theoretical cooling range is the difference between the temperature of entering water minus the wet bulb temperature. Okay? So, another, we have here the makeup water requirements. Okay, so by mass balance, you can easily determine the mass of water. Okay, so M sub 1 multiplied by W sub 1, meaning this is the mass of the water uh, carried by the air. And W sub 1 is the humidity ratio of the air, plus M sub 3, of course, the hot water is equals to M1 W sub 2. So this is the mass of the water multiplied by the humidity ratio of air leaving the tower plus the mass of the cold water. Okay? So wherein also the makeup water can also be determined using the mass of entering water. Okay? Minus M sub 4. Or in terms of the humidity ratio, that is M sub 1 minus or multiplied by the humidity ratio at 2, or the humidity ratio of the air leaving the tower minus the humidity ratio of the air entering the tower. Okay? So, percent makeup water. So, this is equals to the amount of makeup water divided by the mass of water. Okay? So, where M5 represents the makeup water requirements in kilogram per seconds, M1 mass flow of air entering the tower, W sub 1 humidity ratio of air entering, humidity ratio of air leaving, mass of water entering, and mass of flow of water leaving the tower. Okay? So, we have also here the energy balance and the tower. So, that is M sub 1 multiplied by the enthalpy at 1. So, this is for air plus M3. So, this is the hot water. And then multiplied by the enthalpy at 3 plus mass of the makeup water multiplied by the enthalpy of the makeup water is equals to mass of air entering the tower again multiplied by H sub 2. So, meaning whatever is the mass of air entering the tower is the same as with the mass of air leaving the tower. So, multiplied by the enthalpy of the leaving air. And plus the mass of the water leaving the tower. This is now the cold water multiplied by its enthalpy. Okay? So, again, that is equals to M sub 5 equals to M3 minus M sub 4. Okay? So, heat balance. So, the heat absorbed by air is equals to heat rejected by water. Okay? So, that is equals to M sub 1. This is the mass of air multiplied by the H sub 2 minus H sub 1 is equals to MCP delta T. Okay? So, very simple equation. So, where M3 is the mass flow rate of water flowing, okay? And Cp is the specific heat of water. So, that is equals to 4.19 or 4.187 kilojoules per kilogram. Also, we have a specification for a cooling tower. So, when we see a specification, say 40, 30, 20 means that the 40 represents the air or the temperature of water entering the tower, and B or TB or the 30 represents the temperature of air leaving the tower, and 20 represents the wet bulb temperature of air entering the tower. Okay? So, we have also the usual manufacturer's cooling tower efficiency. Okay? So, we have here the approximate value of the efficiency. So, spray pan. The efficiency of that is 50% and below. For natural drop, that is 60% and below. And for forced air induced drop, that is 70% and below. So, take note that the most efficient cooling tower is the forced or an induced drop cooling tower. But actually, when it comes to the cost of operation, the operation of this forced or induced drop cooling tower is, of course, higher as compared to the natural drop cooling tower. Okay, so take note of that. So, another, we have the temperature range, acceptable temperature range. So, that is 10 to 30 degrees Fahrenheit, or that is 5.6 degrees Celsius to 16.7 degrees Celsius. So, take note that this is the usual temperature range. Okay? So, another, we have the temperature approach of 10 to 20 degrees Fahrenheit or 5.6 to 11.1 degrees Celsius. Okay? So, another is for a design requirement. So, we have the approximate power of the pump. Okay? So, or the pan rather. So, pan power required. For every 100 GPM of raw water, it will require 14 horsepower. So, take note that this value can be used in the design of the cooling tower. Okay? So, we have also the common formulas used in cooling tower problems. Approach, difference in between the temperature. So, this was already mentioned so while ago. Cooling tower range already. And we have the theoretical range. So, difference between the row entrance, temperature, and the atmospheric wet bulb. And then the cooling tower efficiency, or the CTE. So, the actual cooling range divided by the theoretical cooling range. Okay? So, take note, class, that the formulas included in cooling tower is very few. Okay? So, take note that application of cooling tower is quite complicated. So, that's all about my presentation. Thank you very much.